So let's say I want to solve this trigonometric equation, and this time I need to be very careful to follow the proper order of operations. I'm going to start by dividing by -4 on both sides because that's the outsidemost thing that's blocking my way from isolating the x. Then I'm going to get rid of the sin, the sign, and I'm going to do that by looking up angles in the unit circle. Finally, I'm going to take each and every one of those angles and divide them by 2. So here's my original equation. Dividing by -4 on both sides, no big deal. And now I need to look at the unit circle, and sine gives me a value of -1 at 3 pi over 2 and all of the angles that are coterminal to that. And so this is how I write that down. Notice at the left-hand side I simply deleted the sin, so I have 2x, and on the right that -1 turns into all of those angles. So I have 3 pi over 2 plus 2 pi k, where k is any integer. Finally, I need to divide by 2 on both sides, and that means dividing the entire expression, 3 pi over 2 plus 2 pi k, dividing that by 2. We have to follow proper fraction math here. I can simplify this if I wish, because nobody really likes compound fractions, and so this turns into 3 pi over 4 plus pi k, where k is any integer. So you might be wondering, why can't I just follow the steps, find a single valid solution, 3 pi over 4, and then add plus 2 pi k to the end of that? And the biggest reason is it actually violates order of operations. So to me, when you are undoing sine or cosine or tan, that means you have to follow the full process of finding every single coterminal angle where the function gives that particular value. Like, you can't just do part of the job and then save the rest of the job for the end of the problem. You have to do the whole thing at that one time. So here's what that wrong solution would look like. Let's say here's the equation that you had, sine 2x equals -1. And then you looked at the unit circle and you said, oh, 3 pi over 2 is where sine gives you -1. And I put it in red because this is wrong, just so you know. And then you divide by 2 on both sides, and then you're like, oh, well, there's infinitely many solutions, so I'm going to put plus 2 pi k on there. So this would be the most common wrong solution that I see. So first of all, there's a few ways to see why this is not okay. It's a general principle in algebra that every equation that you write has to be equivalent. They all have to have the same solution set. That's when you're dividing by 2 on both sides, when you're adding 5 to both sides, you're writing a different equivalent equation with the same solution set. These equations are not equivalent, and I think the most obvious place is right here. Is x supposed to be a single number, or is x supposed to be infinitely many numbers? There's just no logical world in which you get to jump from this equation to that equation, so it doesn't make any sense to me. Secondly, here's the correct solution set from a few slides ago, and I decided to write out all of the wrong solution set numbers in a list, and I have all of the correct solution set numbers in the list as well. And I want you to see that some of the numbers match, right? You have -13 pi over 4, you have -5 pi over 4, you have 3 pi over 4, but this solution set, this wrong one, actually misses fully half of the solutions. It misses -9 pi over 4 and -pi over 4. And you can check for yourself. If you took this number and you plugged it into this equation and you simplified the left-hand side, you're going to find out that it's a valid solution. So if you have a technique that misses half of the solutions, there's no way that that's going to work. So, in conclusion, make sure that when you undo a trig function, you're following the full process and doing the plus 2 pi k, k any integer, or you're writing out the full list of solutions at that time.